Hi everyone. Here I'm going to talk about topic 7, which is a statistic. What is a statistic? A statistic, what I found when I searched, is practice or science of collecting and analyzing on some data. Okay, so we collect some data, we work on some data, just as, for example, representative of the population. I tell you what is population, and we call that sample. Okay, so we want to work on a properties. We want to work on the properties of these samples, and we want to conclude or make conclusion for the whole population. Okay, so we call this a statistic. When we collect data and we work on them, analyze them, and then we find some properties of the data and we say, okay, this is for sample, so for sure, almost, okay, the property of population is the same as this sample. So we want to make some conclusion. What is population? Population is when I work with the whole collection of the individuals, with all the data that I have, which is sometimes impossible. For example, I say the whole population is all the Seneca students. It's hard to work on all of them. For example, to do to do research of properties of them. Okay, so research about the properties of them. So I collect the sample. So means a small population. For example, I choose 1,000 of them. I choose 100 of them. I choose from one program. Okay. Parameter is something related to population. Okay. So a numerical value which summarize the entire population. For example, I say mean value of population. Okay, so when I have something from population, I call this parameter. Okay, like mu. Okay, mu is mean value of population, or sigma is a standard deviation of population, which you are going to see shortly. A statistic. Okay, a statistic is when you are working, as I said there, when you are working with a sample. So properties, something related to the sample. Okay, so a numerical value which is for the sample. For example, if I say mean, I am talking about X bar, and or for example, a standard deviation is S. Okay, when I work with sample, and in most cases you work with sample, so we know this, but in most cases we show this one because we are working with the sample. The whole population is not with us. Variable is what you consider. For example, for the whole population, for example, you want to work on their height, or you want to see how many courses they have. So you talk to a sample and ask how many courses they have, and you collect these data. Okay, so this is a variable. So what you are going to consider to do research about it. Data, when you collect data, so for example, you just all the information you collect from the sample, okay, will be data that you have. Experiment is the process of collecting all these data, the process of all the activities you do on the data. Okay, sample, so simple random sample. So when we choose, for example, a random sample from the whole population, for example, when we want to pick 100 students, okay, so we just pick them, for example, randomly. So for example, we don't say okay, I choose number 1 to 100. No, I choose randomly, when I do it randomly, okay, because I want my sample to be representative of the whole population. I choose it randomly, okay. So these are the terms that we need, and I'm not going to ask you to define it for me. We don't do this. Okay, sample mean. When I collect all the data and I just, let me see if I zoom this way. Yes, it's good. Okay, when I add all of them and divide by the number, it will be mean. Okay, so you add all of them and you divide by the number. So means you add these all here. Okay, so you add them all. So let me, okay, so go here. Okay, this. So x bar is, I say x bar because I am working with a sample. Okay, so sigma xi, I from 1 to n divided by n. This is the symbol I show as summation. When I want to say summation, this means x1 plus x2 plus x3 plus dot 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 xn divided by n. If I have 5 divided by 5. Okay, so this is a symbol, mathematics symbol, a statistics symbol for that. Also, that's mathematics symbol we use as summation. Okay, so I add them and divide by, okay, 1 2 3 4 5 6 7 8 9. I divide by 9. Okay, so here I add them all and divide by 9, and the result is 707. So this is the mean, sample mean. So you add them all and divide by the number that you see. If I make mistake, let me know. Okay, so let me see if I just check. Okay, so 746 plus 574 plus 645 plus 894 plus 736 plus 635 plus 794 plus 645, and then divided by 9. Okay, yeah, so 746, I have to do one more time. It's 574 plus 645 plus 894 plus 736, 695, 635, 794, 645. Yes, this is this, and I round it to 707. Why? Because I want the number of significant digit be the same as number of significant digit in the data. Okay, so that's almost, okay, 707. So now I continue here. Okay, so what is median? Median is what you have in the middle. So you have to organize the numbers. Okay, you have to write them in order, and then tell me what you have in the middle. If it is odd number, it is easy to find in the middle. Is it odd? Yes, here I have nine data. Okay, so I start from the small one, this, and I cross it. 635, and I cross it. The next one, 645, and I cross it. The next one, 645 again, and I cross it. The next one, 695, and then I cross it. 736, then I cross it. So make sure to cross it, otherwise you miss one. 746, yes, I cross it. Then I have 794, then I cross it, and then I have 894, then I cross it. Okay, see, I have 4 here, and I have 4 here, and in the middle one is the median. How about if I have odd numbers? Okay, if I have odd numbers, so just let me go to view and zoom out. Okay, If I have odd number, for example, I add another data 746 and I make them 10. If I make them 10, then I need to again write them in the order. So this is 5 7 4, this is 6 3 5, this is 6 4 5, this is 6 4 5, this is 6 9 5, and that's 7 3 6, and then 7 4 6, and then 7 4 6 again, and then 7 9 4, and then 8 9 4. Am I right? Yeah. Okay, so let's, okay, 5 7 4, yes. 6 3 5, yes. 6 4 5, yes. 6 4 5 again, yes. 6 9 5, yes. 6 7 3 6 3 7 3 6, yes. 7 4 6, yes. Again 7 4 6, yes. So I cross it, and then 7 9 4, and then 8 9 4. Okay, see here I have 5 5, so I have 10 10. Okay, so I do 4 and I do 4. I find what I have in the middle. In the middle I have 2 digits, so I add them and divide by 2. This will be median. So if I have odd number, the same as previous page, I just find what is in the middle. If I have even numbers, so I have to just find 2 in the middle, add them and divide by 2. And this is 715.5. Okay, which I do 3 significant digit to be like all of them, so 716. Okay, so this is the median. How about mode? Okay, mode is what happens frequently, means what happen most frequently. So means what is the data that happens more than once. Okay, so here the data happens more than once is this one. Yes, so this is the mode. Okay, so let me see what's going on. Oops, I go here, zoom out. So I did maybe something. Yeah. Okay, yes. So this is the mode here because it happens twice. Okay, so I would say this is the mode. Okay, so that's the mode here. So did I write median there? Yes, median. So median is 716. And here did I say, yes, this is median. And here I said this is mean, I have to say. Okay, so how about if I have more than one? Okay, so for example I have 746, which happens twice, and I have 645, which happens twice. Some books they say bimodal, means I have 2 modes. Here we say no mode, so there is no mode here. Okay, if I have, for example, one of them happens twice and the other happens twice, so some books bimodal because I have 2 modes, and some books no mode. Okay, so now I continue. Okay, so I see, okay, so yeah, okay, so I see these data and I want to talk about them. Okay, so look at this. Okay, so I want to show you something. I want to show you not always I can trust mean, not always I can trust mode, and not always I can trust median. I have to research about the data. So a statistic needs research. Okay, there is no just one formula that I say, okay, follow this for all questions. No. For example, 5 employees, they have salaries 35,000, 41,000, 35,000, 46,000, which is not a very high salary. But one of them has 150,000. Okay, so you say, okay, what is the mean? Of course, you know the formula of mean. So you would say, okay, mean is x bar. I add them all, 1 to 5. Is it 5? 1, 2, 3, 4, 5. Yes. So I add them all to 1 to 5 and then divide by 5. Okay. So the result is 61,400. Is it a good representative? 61,400 is not close to number 1, number 2, number 3, number 4 because they are almost less than 50. The reason I have a large number is because I have something which is very large and is misleading me. Okay, how about mode? Okay, so mode is what happens twice. Okay, so which is 35,000 because it happens twice. That's mode. Okay, 35k. How about median? Okay, so 35k, you have to organize them, then cross them. Okay, 41k, 46k, 150k. This is median. This is median. Okay, so here, as you can see, median is much closer to most datas here. Okay, so here is not large, so I just want to show you one example. Okay, I have 5 datas, but median is a good representative because 150,000 makes the mean very large and it's far from the most of the data. Mode is also far from, so it is 35,000. It's close to 2 of them, of course, exactly 2 of them, but not a good representative. A good representative here is median. So it doesn't mean always a very good representative is mean, always a very good representative is median, or always the good representative is mode. No, you have to do research about the example that you have. Okay, so here it's talking about it, explaining. Okay, so the mean, okay, so the mean is not a good representative because this large number. Okay, the mode is also very far from some of them, so it's not a good representative. Okay, median is the best representative because it's close to 4 of them, so almost just in the center. Okay, so I zoom out and then I continue. Okay, so again it's continuing, just explaining the same thing here. Okay, so let me see if I zoom. Okay, yeah, now we want to talk about accuracy, precision, and if the data is reliable. Accuracy, I say the data is accurate if the measured value, what I find, okay, this is you find, for example, if the measured value that you find, for example, in the lab is close to actual true value. So actual true value, maybe it comes from your teacher, maybe it come from lab manual, maybe come from the, for example, it's written on the, for example, the sample, for example. Okay, sometimes we don't have access to actual value. Precision is says how the measured value that you find is close to each other, how they are close to each other. So for example, you measure something for 5 times. If they are very far from each other, then something is wrong. You are making mistake, or what is happening here. I say something is reliable if it is accurate and also precise. Both case is something that I see. They are close to each other, also they are close to true value. Okay, I can show it here. Here, they are close to each other, precise, but not accurate, because they are not close to this part which is actual value. Here they are close to actual value, but far from each other. And here both of them, so it's reliable because I have high accuracy, close to the true value. Also, they are close to each other. Okay. So now I continue. Okay, so every time I have to go here and zoom for this lesson. Oops. Yeah, let me see if it's working. Yeah. Okay, so how do I calculate accuracy? Okay, as I said, accuracy is when the data is close to the real value. Okay, so I find my data or your data, or for example the data that you find. Okay, you calculate, what you calculate is here. This is the true value. This is xi, and this is the true value that you have. So for example, your teacher says, so xi, the thing that you calculate, minus x, which is the true value. This is the error, and it gives me accuracy. Error doesn't tell many things to me. I just find what is the difference. What is the difference between data and the true value? But if I want to see what is really the error, I have to calculate relative error. Means I do xi minus x divided by x. Means I compare this difference, which is between the data and actual value. I compare it with actual value to see what proportion of actual value is the error. Then if I multiply it with 100, I said this is percent relative error. So if I want to find percent, I multiply by 100. So here is, this one is xi minus x divided by x multiple 100. And then I show it as percentage. Okay, so precision, as I said, how they are close to each other. So I don't think about the true value. No, how the measured value are close to each other. Oh, okay, so let's see. For example, I have x1 and I have x2 and I have x3 and I have x4 and I have x5. How they are close to each other. So I find difference of this and difference of this and difference of this and difference of this, and then I find difference of this, and then I find difference of this and difference of this, and then I find difference of this and difference of this. So it will be so much calculation. So I don't do that. I define deviation. Deviation is when you find subtraction of xi minus x bar. Means instead of you compare these data with each other and find all these colors that I did, all these differences, you compare them with the mean value, because mean value is just in the middle. So mean is in the middle of all of them. So you compare each with the middle, and you call this deviation. So the difference between xi and the mean value. So remember, we are doing this for precision. Precision means how data are close to each other. So we don't think about true value here. Oh, okay. So then I do xi minus x bar divided by x bar because I want to see relative. My goodness. So okay. So I stop here and I just fix the problem and come back. Thank you.